Hello, everyone. We will give 1 minute and get started. Subhash, when you are ready, we can get started.
Sure.
Hello, everyone. Welcome to our second webinar in the Master Series. As we continue to demystify building sophisticated software systems, we want to bring many topics through webinars in simple and practical terms on how we can implement them. One of the things we have noticed often is that when someone introduces a system to us and says, take a look at it, what do you think about this system? It takes so many questions, so much work to understand what that system was about. Whether a system that has been built by somebody transferred to us, sometimes we are asked to do a due diligence for an M&A, or sometimes we transfer a system to somebody else. At all the times, to understand a system, to do anything with it, it's such a complicated and time-taking effort. The entire value of a system seems compromised because it does not have an equivalent to a manual or a documentation that highlights, that explains the system in a practical and an intuitive way. So here in this webinar today, what we want to focus on is how can we consistently, coherently, always keep a lockstep approach from the requirements level all the way to the software code through multiple steps as requirements get translated into architecture, detailed specifications, test plans, coding. How do we maintain that coherent and consistent view, which will help us to maintain the systems as well as help us to realize the full value of the system. To keep it very simple, we will discuss this in approximately 30 minutes. I invite Subhash to walk us through what the problem is in managing this consistency and in realizing the true nature of a system that is built. Subhash, please take it away.
Thank you, Sinu, for the introduction. It sounds weird, right, when we say business requirements have to be kept in sync with the software we build. After all, we build software based on these requirements. But the key word is sync. Yes, we are in sync automatically on day one, but over time, as the product grows, probably with user feedback or new use cases that have come in, or even attacking new domains as part of your business, the old requirements may no longer remain true. So keeping requirements current is a challenge. Now, it's one thing for requirements to go out of sync, but it's entirely another thing that sometimes we don't even know what the requirements were. And sadly, most products in development today have this weakness. They share this weakness. So today we are going to explore how to define requirements in such a way that they're easy to capture, easy to maintain, and are automatically carried forward with the product forever. First off, we have to remember that all written knowledge is stale. The question is not about if it is stale, it's about by how much its tail is. Sometimes it can be weeks old, sometimes months. Ideally, we would want documentation to not be too far behind our software. Why is that? Because the most important, and it's usually forgotten, the most important aspect of developing software products is that there is a need to deliver faster with time. As users increase, as the product grows, we have to be able to iterate faster and produce more value to customers. All the things that we do, like software architecture, system design, using flexible frameworks, having better teams, all of them are geared towards this goal of building sustainable software so that there is minimal or no increase in complexity over a period of time, and we can happily run fast forever, preferably. But one can argue that knowledge is probably more important than the source code because it's acquired along the way. Think about questions like, why is workflow X better than workflow Y? Why shouldn't we target this kind of user among all other users? How does this feature actually help our customers? This knowledge is often the product's differentiator and is acquired through a series of decisions that are taken over time through experiments and learning. Acquiring it takes real dollars in the form of effort, time, and resources. And you're going to spend it anyway if you want to grow as part of the product building exercise. So why not keep it around? Because without this information, critical decisions that you took in the past are forgotten. The experiments that you conducted will be repeated again. Delivery cycles will stretch because there's a bit of trial and discovery in everything that you do. All products that we know of are somewhere in this continuum between no documentation and wholesome documentation. But the bet is living documentation, as we'll explore in this webinar, gives you a nice balance between cost and resources. How is knowledge preserved in our software usually? Typically, it's translated into documentation of some kind. It's already present in the product, but may not be easily distinguishable or accessible to users, including developers. It's in product specs that were written based on which the source code was written. If you practice test-driven development or behavior-driven development, it's also in test cases that drive the feature itself. And these test cases are usually rich as a collection of edge cases and exceptions. There are also other product artifacts that may not strike us as knowledge, but they're important nevertheless. User guides, onboarding manuals for end users, videos on something like YouTube that introduce your product, even infrastructure code that helps you build and deploy your product into a computing environment. All of these are sources of knowledge. Why? Because they all preserve and transfer knowledge between people and across time. If this is the case, why or who wouldn't love more of it, right? Did more documentation ever hurt anybody? Unfortunately, there are some potholes or often repeated mistakes when you start practicing good documentation. It's typically treated as a separate activity from development. It's supposed to follow after development, but as we all know, it rarely happens. What's more fun, coding or writing documentation? Plus, most of this documentation is manually transcribed. It tends to be duplicated, it tends to be redundant, and is simply a brain dump that is isolated from the rest of the product. Even when done diligently, you can head in the wrong direction because some people can be too notation obsessed or by producing extremely polished diagrams. Documentation is supposed to serve as knowledge, not as a showpiece that is beautiful and not so useful. So there are inherent flaws that we build along the way when it comes to documenting the knowledge that we acquire as we build our product.
Thank you, Subhash. I think it's very clear that everyone loves to have that documentation that is clear, captures the system, reflects it. That's useful for everyone when you either sell your system or transfer to somebody, or you want to go back and fix something, maintain it, make changes, etc. But it's also clear that it's not easy to do. In fact, it seems like nobody can do this documentation really well in a way that's really useful and connects from the requirements to the code. Then what are some good solutions? What is a suggested approach in how we can actually create this documentation without having to invest all of our time and still fail at it?
Well, big companies already do it. Take Google or Microsoft as example. They have the luxury of employing teams specifically for documentation, and you can see the output. It's pretty good. But for the rest of us, mere mortals who are simple startups and who are beginning our journey on the product development roadmap, we need something simpler that is cheaper and easy to implement. We want a sustainable process that does not let the process of documentation slide, avoiding all of us getting into a region of dead knowledge. We want documentation that basically lives, which is alive. And what does such good documentation look like? First of all, this documentation has to be reliable, it has to be trustable. We want it to be accurate and representing the product all the time. There has to be a mechanism, in fact, that guarantees the accuracy of this documentation. It should take as low as an effort as possible to maintain, and preferably rely on automated tools to do most of the grunt work. We don't want to take on the tedious work of writing documentation every single time. It should ensure that the knowledge stays evergreen, because iteratively the product gets built over a period of time, and we don't want that iteration to destroy the knowledge that we have built in the past. It should be collaborative. It should promote conversations and knowledge sharing. It should be easy to share. It should be easy to understand and easy to add to if somebody sees something is missing. It should also, at the end of the day, provide insight. It should encourage all of us to think deeper, should allow us to explore opportunities for feedback, and generally help in making better decisions. So if these are aspects of good documentation, what qualifies as good documentation? Should we capture each and everything that we do as part of our project and call it documentation? Yes and no. We want to focus on everything that has to do with the product, but only on those parts that give us the biggest bang for our buck. We want to focus on information that will remain relevant over a long period of time. A typical product lifecycle takes anywhere between 3 to 5 years for initial growth beyond market capture. So documentation has to remain relevant for such a long cycle. We also have to spend time and effort in maintaining information that is important to a large number of people, especially when they are spread across geographies and time zones. And you know that the current situation that we are in, where all of us work remotely, the same aspect applies here as well, because we are disconnected, and documentation has to act as bridge between team members. Also, we want to safeguard important information related to our product's differentiation, its value, IP, and processes. To be able to do this, we have to go down to the roots of how we work. In fact, we want to organize in such a way that everything we do in our product development lifecycle is treated as knowledge. So let's talk about starting from the get-go. We want our product's vision, value proposition, hypothesis to start getting documented. From these value props, personas and specs will flow, which will then be implemented as part of the application in the form of source code. Then, using the right technology ecosystem that we currently have, we can automatically extract more knowledge from the work we have done. We can build up glossaries from key terms we use in source code. We can leverage comments that developers add as additional explanation to code that they write. And using open source tools, we can even generate dependency graphs from the source code, which are valuable for understanding the different elements in our product. and they form connections and workflows between the different elements. At the same time, the system can expose functionality that is still in the system but no longer relevant. Maybe it is leftover code from a year ago. We can maintain history in the form of specs, but it is always better if the product models reality and we keep it extra lean. This is what we are going to call as living documentation. Documentation that changes and grows over time with the product and is treated as a first-class citizen as part of the product. There are many possible mechanisms to it, but the most promising that we have experimented with happens to be something called behavioral specifications. Now, BDD, as we call it, behavior-driven development, is about using plain English statements written in some standard format, of course, to drive the development of the system. There are two parts to this process. Specs that are written in English-like language, typically by product owner, developer, and a third person, like a tester. They three together are called three amigos, usually in product parlance. And the other side is the source code that is written to satisfy these specs. At a glance, it seems like redundant. Why are we keeping two copies of the same information? But this redundancy is purposefully built into the process to ensure that two parts have to stay in sync. When the specs change, the behavior of the product does not change, the specs will break, an error is reported. Same is the case if the product changes without updating the specs, we will see an error in the build process. Now, you may have a process that guarantees that the documentation is reliable and 100% correct with system behavior if you follow the rules and make these two copies of knowledge always in sync with each other.
Thank you, Subhash. So there is a process where documentation is not an afterthought, or as you called it, a secondary citizen or a second citizen. It is a part of actually how we do the project. And anything and everything done by the key people in the product team, such as the product owner / product manager and the developer and the tester, how they write anything, whether it is a requirement, an architecture, a code, how they write the test plan, they all contribute to becoming actually the documentation that reflects at that point whatever the system is. It's never really decoupled. And in addition, it seems that it comes without having the heavy penalty of having one more exercise of writing like big books of documentation after something is built, which may or may not change with the system. So there's a lot of good things in this, and it's a living system, like you said. So it changes as the system goes, as long as everybody is contributing with an approach that contributes to having a documentation. So it seems like this whole living documentation is as much about having a kind of an SOP, a standard operating procedure of how you are creating this knowledge. Now, can you give us an example and how these key people, the three amigos, as you mentioned, what they do contributes to have this documentation that becomes a part of the asset, the intellectual property, along with the system, how it enhances the value of the system?
Sure, Sinu. And for our example, let's pick up something that everybody can understand because we have it as part of our daily lives. Let's pick a problem from the financial domain of having to transact using our personal bank account. When you express a requirement in behavioral specifications, you adhere to a format we will see shortly and understand what it is, but you are trying to model three aspects. One is who is doing the activity. I am the account holder and I'm going to do an activity in this case as an example. What is the action that I'm going to do? I'm going to withdraw cash from an ATM. And when I do the action, when I withdraw cash, what is it that I benefit from? Why would I do it? What is the value that I'm getting? I can, by withdrawing cash from the ATM, I have now the opportunity to get money even during non-banking hours. That is the value that the system is giving back. So when such a requirement is written in this format, it has these three components that express who the person is, what is the action they're taking, and how do they benefit by taking that action. There are many other examples that are on the screen. One was the withdrawing cash example. The other is, let's take the bank teller example, where I'm now on the side of the bank management itself. And as a bank teller, I want to be able to deposit an amount that the customer gave me so that I can credit the amount back into the customer's account. So these are all examples of how a problem statement is envisioned and the benefit is associated with it. So stepping back, if you look at all these examples, you are seeing these common patterns. There's a persona who acts like depositing the amount or withdrawing the amount, or in the bank manager's case, opening the business day. So they're taking an action on the system on a specific element. What is it that you're transacting against? As a person who walks into the branch, I might be transacting on my account. As a manager who's responsible for the bank's operations, I might be doing something with the branch of the bank. So there's an element in the system on which the action is being conducted, and there's an effect that is being produced. Maybe because of the transaction, I should receive an email or an SMS confirmation, and my account has to be debited or credited by the amount, or an end of day report has to be generated. So you see these common patterns emerging from these specifications. And these common patterns help us get to the next level of writing out specific scenarios. The first example that we saw is what we call a feature. We want to enable a functionality in the system for our end users. Now we'll drill down one level further and say, let's assume that we are going to build this feature. What are the different aspects about this feature that the system has to support? This has yet another format, which is written from a scenario point of view, where there are three clauses that we use as a standard. There's a given, which is setting up the environment in which the action will take place. Let's take one example and walk through it. Given I'm a valid account holder and I have an active debit card and I have sufficient balance in my account. So I've set up my world. I'm giving a clear idea of what the current situation is as an account holder from my bank account perspective. Then I conduct the action, and I use when to depict the action. When I try to withdraw cash on an ATM machine, I'm conducting an action on the system, affecting the system. Then I highlight the effect of my action using the then keyword. Then my account should be debited for the amount and the money dispersed from the ATM machine. So using a series of given, when, then statements, I express all the things that happen with respect to this particular scenario. Now, it's shown in green because it's a happy path, which means that the world is good and everything is fitting into the model that we assume, and I'm able to conduct the action successfully. But there can be failure cases as well. For example, if I don't have sufficient balance in my account and I try to withdraw more, then the transaction should fail and I should get a message. All these examples fit into what we call as scenarios, and they all form the part of execution for the feature that we have highlighted at the top. What is better in terms of specs is when you give concrete examples. So instead of talking in broad scenarios of I have sufficient balance in my account, I now want to give a value to that sufficient balance. As an example, let's say that I have $1,500 in my account and I want to withdraw $400. It's so easy, it's so much easier to understand that when given concrete numbers, I can withdraw $400 from my account, right? So specs, when written with concrete examples, are better than specs that are written in broader statements. They make the system and the developer who has to develop this specification understand the requirement very clearly. That's why behavior specifications are usually also called specifications by example, because when you write these specs, You don't write them in the form of paragraphs or large documents. You write them in very small pieces and also with concrete examples, data that you can use in the system and test against. Now you can step back and see how living documentation takes shape, because the moment we use these behavior examples, uh, we are actually contributing to the documentation process right away. Personas and key terms can be derived out of these specs, and they're guaranteed to be in sync with the product that we develop. We can also depend on machine generated behavior or machine generated software or connections that to discover new opportunities. And we can also figure out issues and old functionality that might be still lying back in the code. And in general, we have a better visual way of understanding what the system is doing in the background. In the screen, you see that the glossary has been derived from the specs. The personas can be derived from the specs. The examples that we noted down earlier are already maintained in the specs as test cases. As an extension, we can also plug in open source tools, for example, that analyze the different players in the software and generate a visual depiction of the workflows that happen between them. So as long as the source code is at the center and the specs are being used to drive the development resulting in source code, and from the source code we can extract all these aspects like glossary, key terms, personas, dependency graphs, we now have a system that actually is revolving around one central area, which is the source code. And the source code is the most important part in the form of product functionality. What it does is the single source of truth. So as long as you drive documentation from the single point of view, your entire world of knowledge revolves around the single source of truth. So you tend to change things everywhere when you change the source, which is the source code, which is the functionality of the system. And that's why the documentation can be called as being alive, because it's changing as the product evolves.
Thank you, Subhash. So it's a good example, easy to walk through how everything comes through. Now, let's relate to how, as an individual, these things apply to us. So it seems to me that everyone has a role in building up to having this living documentation. Everybody has a role of contributing as well as expecting how this is coming together. And that seems to come from two parts. One, sticking to some kind of an approach or or an SOP, a standard operating procedure. That's number one. And number two is having this understanding that this living documentation is an important aspect. It's as important as the code, actually, like you said, and contributing to it. So here is a set of actions to see if we can think about our current project, current product. And the first question is, what are your thoughts on the documentation for your current product? On a scale of 1 to 10, if we apply the principles that we have discussed here, what good documentation will accomplish for you? Basically, living documentation means, let's pick up the top 3 things that Subhash has been talking about. They reflect what the product is doing very easily. They're always up to date. The second thing is it's actually readable. It reflects without having to spend a lot of time. You can understand what the requirements are, what the expected functionality is, and what the system does. And third thing is, how complete is it? The things that Subhash talked about, it's valuable, it's insightful, it's educating. And when you look at it, it's not just a whole bunch of words put together, but rather the substance. So on those metrics, how would you rate? Please type your answer in the chat room. Someday we'll go to like a YouTube version where the comments will capture and keep these things for a long time, but we will use the chat. If you have a question on this action item, please go ahead. So the second one, sorry, Subhash, were you trying to say something?
I also wanted to add to that question, Sinu, that it all starts with the intent to maintain documentation to be in sync with the product functionality. You can be at one or you can be at five, but the process is more important over the long term than actually where you are right now. I just wanted to highlight that in addition to what you said.
Absolutely. That leads us directly into question number 2. So if you look at this documentation not just as a piece of paper or a bunch of words on your computer, but actually the documentation process itself, where, if you see any, where are the gaps that could be improved upon? So the gaps could be thought of as a place in the whole pipeline, starting from the idea or vision all the way down to the code through multiple steps, whether it is a fully written requirements to architecture, to some specification, to testing, to test plans, anywhere. Where do you think you may have an area where that can be improved? And the other dimension is in terms of with whatever you have, either the quality or consistency or the usefulness a gap. So in these two dimensions, one is actual a particular functional process in your whole pipeline, and the second one is in the dimension of software variables like quality and usefulness and completeness. Okay. So just to reading the answers, gaps are in details. Okay, excellent. So now moving on from there. So since there are different roles in the most minimized or optimal version, there are 3 primary roles of a product manager, a coder, and a tester who bring the product together. What can you contribute, either from yourself or by expecting this from your team members? What can you do very specifically, 1 or 2 items, to help improve the overall documentation of your project? Thank you for answering these questions. And actions matter. We think at the end of the day, we can talk about all the models and theories, but how we take anything away, even if it is one little bit that contributes to one little project, we are thrilled. We are happy. We think we have done something we wanted to do. So hope this has been useful in whatever format it's useful for you. If nothing else, just as an understanding of how things work. And if you have any questions, if you can be of any help, please feel free to type, and we are here to answer, whether it is now or even as a follow-up.
Thank you, Seenu, for hosting the webinar.
Thanks, Subhash. So we will log off at this point.
Thank you, guys. Bye.